Hello and welcome to my channel. This is where I want to discuss the web development I do with TypeScript, and I've got a new web page to talk about, the chess page. So that's right here, and let's play with it and see what you can do, and then I'll show you how it's built and how you could maybe also build things like this. The source code is available, you can download it so you can have a good start, and then you can change whatever you like. I wish you good luck with it. So let's see what this is right now. So I built this a couple days ago. I started building this, so it doesn't have that many features yet. We've got 4 ways to play. One where we just let the computers play each other, which I'm doing right now. Then you can also have a mode where you can play everything yourself. Um, and then there's one, of course, where you're white versus a computer, and one mode where the computer is versus you. The computer starts with white, you are black. And you can also, amazing feature, rotate the board. And it visually rotates the whole thing, and then you can play onwards from there. That's also possible. Okay, so like it says here in the bottom, it says powered by Stockfish chess engine. And Stockfish is a very famous engine, and I was watching some chess videos, and I always saw Stockfish mentioned, wondered whether that engine was also a JavaScript version for it, and it turns out there is. There has been a port, JavaScript GS, so that's perfect, and I started using it. So I mean, this is chess. I guess I don't have to show you much more. I mean, you can first of all notice that when I try to move a piece, it tells me where I can move that piece. And also, if you are in range of a piece, it can tell you, that you can capture it with visually. It also shows you the last move that was played. And obviously, you can let the computer do all of it, which is amazing. And this computer should also be at a very high difficulty level. I've kept it on the max settings and gave it about 3 seconds to think. The maximum is 5 seconds the way you can configure it. So I figured, oh well, 3 seconds should be enough, and then you can still get a relatively quick playback when you're just looking at it. So now let's go over the code. Let's dive into this, right? For people who want to really download this code and maybe make changes, create it, put it in their own website, stuff like that. So maybe the good place to start is with the store. By the way, I have a video out where I explain the setup for this entire website except the chess page, because that's new. I also now have a GraphQL API implemented in the API side. However, this video is just going to be about chess. I might make another video about GraphQL and MongoDB, but for now, let's focus on the client side. So we can start at the store, and the store is where all the data goes for this state. And I can maybe show you that store better using the Redux DevTools. So here we have the total state of the entire application, which is for the user that's logged in, for the Slack is for the messenger, etc., etc. But here below we see chess. Now I'm going to pin that so that we just open that and just show this part. This is relevant for this video right now. And here we see a bunch of interesting properties, and I just want to go over them so you understand what they are. The fen code is a code that the engine uses that you have to send to the engine before you ask it to come up with the best next move. And so this represents the entire state of the board. The first one, the first part of it, before the first space, you can see it's every single row, right? You can see rook, king, and the numbers I believe are empty squares. I mean, I know are empty squares on the board. And so here sometimes you see higher numbers. Here's 4 empty ones, then a queen, then a knight, which is n. And also the capitals mean something. If it's capitalized, it's white, and if it's lowercase, it's black. And so you can see this entire state of the board in this first part. However, to really make it complete, you need the color whose turn it is right now. So it's white and black alternating, right? You can see that here. And then if I start a new game, you can see the complete state without the dashes. Oh, I need to start a new computer game there. Now you can see that this represents the castling ability of both sides. So here you can see that the king can castle both on the queen side and on the king side for white, and the same is for black, right? And slowly, as pieces get taken, or maybe the king moves, then he wouldn't be able to castle anymore. So then these numbers, or I mean these values change, these 4. Then this is for an en passant pawn. So if I move a pawn two squares up, then the square below it would be passed. That's the en passant square, and that one is notated there so that the engine knows that if it can capture with another pawn by moving its pawn to that square. That's notated in that part. And then these are counters. These last two are counters for the half round and the total rounds. I think it's the half round since last capture. I'm not sure. Well, anyway, there's a notation, and this is used, I believe, for the 50 turn rule and stuff like that, where if you have too many turns where no pawn is being taken, or no pawn is being moved and no other piece is being taken, then that number keeps going up and eventually you have a draw, a stalemate. So this is the thing that the engine uses, right? But I also wanted a more stripped down version of this string, because it's very heavily annotated, and I don't want in my code to keep checking this string in weird ways. I want to kind of have clear, nice properties. So that's why I have these other properties that sometimes or very often represent the same kind of information that's inside this fen code. Here you can see the turn, obviously, white, white, black, white, black. But I also have further down the user color. And that one is not just white or black, it can also be none or both, which means we have either, of course, both sides being done by a user, or it means that, like in this case, no one is controlling the board, it's just machines, just the engine. So then it's none. And then there's a couple loss conditions. So no material obviously means that we only have a king left, or a king and a knight, or a king and a bishop, one of those three on both sides. In that case, there's not enough material on the board to create any checkmate, and therefore it is going to be a draw by insufficient material. And also we get this interesting array from the chess engine. We get this array of legal moves. So these are all the possible moves in this particular state of the board that are allowed to be made. And we can filter this list to get the squares to show up on the board. To show the little circles that show where you can move, right? So like I said, these. And these are, I think, very critical to the experience of chess, that you can see where you can move. Especially when you're in check, you try to move a piece, it doesn't show any movement that you can go anywhere, and then you know, oh wait, I must be in check and I must have overlooked. So it's kind of a usability thing, and it's definitely important. So that's why the legal moves are here. And what else? Well, we can go from top to bottom. We have the pieces here separated, and just the pieces, so I can easily loop over them. And there is, of course, the row and the column, and then the color and the name. And again, the name is the same format. So lowercase means black, and R means rook. So this is the black rook on 8A, right? So the very simple system. And then I can show it in the interface based on this. Then we got all the squares, which are 64 squares we have in total. And the square is only is usually null, and it is only something if a piece is inside of it. And then you can you can select a piece that way too. So you can select a piece through the squares, or you can select a piece by looping over the pieces. And I didn't want to always loop over the squares because it's 64. So I thought maybe for sake of efficiency, I want to have a separate list, but they refer to each other internally. So anyway, so squares and pieces, the most important ones. Checkers is, of course, all the squares that have a piece on it, and it's just a coordinate, by the way. This comes from the engine. All the squares that have a piece in it that point that give a check basically in this board state. Right now, nothing is in check. Game number, which I use to when you click one of these buttons, one of these buttons, it increases the game number, and then there's a use effect in React that updates and starts the new game. rotated, obviously, because I can rotate. Boom, true, false, so that's what that is. En passant, I explained, so right now there is no en passant square, no pawn has moved 2 up, so that's easy. Dragging, so this is perfect. This is for when I'm dragging something, like you can see now, it tells me the piece that I'm currently dragging. Okay, and then the latest move, obviously, the move that's been last played, which is also used to color these, color the squares on the board. Castling, which is again that same format I already explained in the fan code, and it's just repeated here, that part of it. Half move clock and full move number, which are also those last two parts of the fan. The reason I want all these variables is because I also create new, if a player makes a move, or even a machine makes a move, the engine, I generate the new fan and submit that to the engine to then evaluate it and then make the best move after that. Right, so I need to keep all the pieces of information that were required to make this. I need to keep that so I can generate it myself as well. And then the last one is request promotion, which is a very nice one, because of course I need to, as a user, select what I want to promote to. So let's quickly go towards the end here, so I can show you a promotion. Oh, we got a bit of a problem here. We're check. All right. Hopefully I can move my king. Boom. And now it shows you the promotion and you have to pick one of these. Boom. Now it's a queen, right? So that's how it works. All right. So that is that request promotion. It becomes true. The game kind of pauses and you have to pick what you want to do. And then the latest move, as you can see, shows that I picked a queen. Because of that loss, it's the coordinate of the move. Plus, for the promotion, you do the special format where there's a one extra letter which represents what you picked, always in lowercase. Anyway, so that's all the properties that this system has in the store, and everything you need to create this visual, right? So let's go into the code now and look at the store itself. Look at especially the reducers, because as you know, in Redux you have a state. And again, this state also has a TypeScript definition, so you can see exactly what each of these properties expects. List of strings, boolean, number, and in some cases a more advanced object that you can define somewhere else, so piece, and you can see a piece's name, row, column, color, and whether it's taken or not, right? Okay, and the square as a piece or an index, but it can also be null. So only if it has a piece, it exists. If it doesn't have a piece, it's just going to be null. All right, perfect. So now we've explained all the types that you can have, shown the state, and now the reducers. If you start the chess game, it's gonna fill in. It's gonna take everything that the initial state has. So if that state has changed, it puts it back in. A fresh one, a reset, so to speak. This is what I'm doing by taking the initial state again. The game number and the user color we keep the same as the previous state already has, so we don't reset that. Those two stay the same. And then objects that are how's called lists get reset. So here all the pieces are being put back into the board fresh, and this is just a regular starting position, right, with all the pieces there on the right square. Okay, so then there is a general purpose reducer for set chess. Now, I usually do this. There's actually a super extreme version of this reducer here, which is just called set, where you can give an object in the payload. Let me show you how it looks like, by the way. But you can give an object in the payload, and it merges them together with the object with the main state. Right. So here the main state gets merged with the payload, and with set chess you're doing the same thing. You're just merging it, but you're merging it within chess. Okay, so now I want to show you how that's used. So set chess. Oh, there it is, set chess. So here, for instance, at the end of a drag, this is the end function. When you let go of the piece, it does all kinds of stuff. And at the very end, it will set the chess dragging back to null. All right, so this merges with the state, keeps all the other properties the same except the ones that I mentioned inside this object. Those get updated. So that's how the set chess reducer works. Very simple, very powerful, because you can basically change the entire state through this. But sometimes there are cases where you have a lot more things you want to do, calculations you want to run, and then you create more advanced reducers. So in this case, a set available squares is a good example, because the engine is just going to give me what's called the legal moves, which have been set already with the set chess. But to set the available squares, I want to do it on a specific coordinate. So I have one specific square, right? So I select one, for instance, this one, or actually I'll probably check here. Let me just restart this one. And now this is the one where I want to calculate the available squares for this guy. And I know I have all the legal moves that can possibly be played, right? So I just have to filter them, and that's what this does. This takes an action payload, which is a coordinate, and then checks whether the inside of the legal move, we're looping over these legal moves, we're reducing over them, and we're generating this squares array of strings. By checking each one of them, each one of the moves, and see if it starts off with the coordinate that I just selected, the payload, the one that I just clicked on. So if the index is 0, that means that this is the legal move for this particular piece you've selected. And in this case, we push the rest of that move, so the last part of that move, 2 to 4, so we move it into the list, and that is the available squares, and then I can draw those dots that you saw. Right, so that's the set available squares. Very nice function, and really leverages the power of the engine giving me already a list of legal moves. Right, if I didn't have that, in fact, originally I didn't know that the engine could produce me this list. So I was trying to calculate myself in a very roundabout way by trying to go from when a piece you select. I wanted to go in every direction that piece could move, and then you have to also check whether you're pinned, right? For instance, if there's a piece here, a queen here, you can't move forward because then you would be checked. So it's very, I had that actually manually programmed too, so I could look for things that are pinned, and it became horrendously long. It was longer than the rest of this file now. So this single reducer became way too big, and after suffering for a couple hours, I was almost there. I almost had the final kind of bug-free version, but I did get that feeling that I often have when programming goes into the wrong direction. You get that kind of, if you have enough experience with it, you start feeling like you're building a Jenga tower that's about to fall. And even if there were no bugs, like it was kind of working, but it still felt like not correct engineering. And at one point I thought, wait a minute, why am I only using the engine to the chess engine to play as a computer? I can also let it do some calculations for me around the board state, whether if I can get it right from that engine. And turned out I could. So I'll show you later how that's done and the kind of messages I get from the engine. Actually, let me show you now. So we can look at, here it is where I start the engine. It starts inside of an iframe. And the actual engine is also hosted on my AWS account because it's like 2.2 megabytes of compiled code. I didn't want that to be hosted on my server because then my monthly bill is going to go up a lot. So I just put it in my S3 website, and there I put a little HTML file, Stockfish HTML, which loads the engine, loads the JavaScript, and then starts talking to it. And then I talk to this HTML file using the post message, the window API in browsers where you can talk to an iframe, for instance, even if it's not on your within your origin. So we're doing a cross-origin request, basically cross-origin resource sharing. Really, we're doing through the post message and add event listener message mechanism here. And then you can also see that here I check when I get a message onto this window. I mean, this message could come from anywhere. I actually saw some other messages from Redux, for instance, come in. But I filter those out by saying, no, the event source has to be that iframe. right? The content window of that iframe. And this is the iframe right now. Engine current is a reference object I create that will, and here you can see that I create the iframe, I append it to the body, I add the URL to talk to Stockfish, and then I put engine current as the iframe. And then engine current content window will be the window that I need to talk to. That's the source of the event. So I can post messages to it, and I can also listen for incoming messages with that source. All right, so that's how it works, and then I can get messages. Now I can console log this message, and then you can see everything that that engine has to say, which is a lot. It's a very talkative engine. It says way more than I even need, but yeah, I've found no way to shut it up, and it's not in debug mode. So all right, so we need to go localhost instead of LukeGG, of course, because I want to make changes. And here you see a bunch of things that this engine starts to tell me. I mean, it's fast, but we can slowly go over it. It's really cool to see this engine do its work, honestly. So first of all, we have a little introduction, Stockfish 11. It says a bunch of people who worked on it. And again, thank you, by the way, to all those people. I mean, this is an incredible engine, and especially this JavaScript port has been a real lifesaver for me to be able to build this, because it would be so boring not to have an engine to do this, to be your opponent, but also to have the engine calculate game states and figure out whether you're checkmate or whether there's insufficient material. Um, Actually, the insufficient material I do myself, but anyway, the engine is of great help for creating a fully featured chess game. You need an engine, basically. Okay, so now we have it tells you all the options that there are, and there's a lot. I have almost changed, I've changed none of them except one. Let me see which one again. I changed the minimum thinking time because it used to be very low. The default is 20, right? And 20 milliseconds, and I thought, I mean, it goes very quickly, but it's also kind of dumb. It doesn't think that deeply. It doesn't take much time to go further into the position. But and the maximum is 5,000 milliseconds, so that's 5 seconds as a minimum thinking time. But I put 3 seconds as my minimum thinking time, trying to find a balance between not having the user wait for too long. When you're just watching two computers play, it gets kind of boring if you have to wait 5 seconds between every single move. But 3 seconds is kind of passable, kind of okay. And obviously, I also added this nice loader here, which is even better when it's user versus computer, because then you can see you move and then the computer is thinking, right? So, and it at least it gives you something to indicate that your opponent is going to do something. Don't worry about it. It hasn't crashed or anything. So it's just a little bit of a visual feel. But anyway, so that's what this option change does. And it tells you all the other options you have. One of the things I'm definitely going to implement later is the skill level, which right now is at max. But I thought maybe I could maybe change it so that you can play versus an easier computer and give the user a bar so they can select how difficult they want it, basically. Okay, now then there's this up and down talk where I will send to the if the message is UCI OK, this means the Universal Chess Interface, I think, which is the way that we talk. I have to tell the engine that that's the way I want to talk. So that's what I do here. Please, here I say UCI, Universal Chess Interface. So that's please what I want to use. And then it will respond with, oh yeah, that's okay. UCI, that's okay. Perfect. And then again, when it says that, then I'm going to ask it, okay, are you ready? And then the engine is going to respond with, ready is okay, right? I'm ready. Let's bring on this game. Okay, and then I say, okay, UCI new game. We have a new game. We're going to start a new game. Perfect. And then the game is off, and then it depends what side I'm playing. So I can check here if it's none, or if the user is none, meaning the user is not playing at all, it's just two engines versus each other, or the user is black, that means that the first move is up to the engine. So the engine is I'm gonna say, okay, start in the start position, which is a special variable. Usually you give the fen code, right? Like I told you before, but for start position, there's a shortcut. You can just say position, start position, and then go. And then this is that important part that I found later that you can do this, D. And D gives me the complete game state. It sends back, and that's what you see here actually. The first thing you see is the game state, which is perfect. That's exactly what I need. And here you see that fan code that I'm gonna need. And you see the checkers, and it's empty, so nobody's in check. And this is the most important of them all, the legal universal chess interface moves. And I can use this to create on the interface those dots, and I can also check whether there's a stalemate, for instance. If there are no checkers, but you also have no legal moves, that means you would have a stalemate, right? That's that moment in the game, which is so frustrating when I was a starting chess player, that I would always end up in this situation where I thought I was winning, and then I moved in the wrong way, and the opponent had no more legal moves, but I also didn't check him, and then it would be stalemate even though I was winning. Very frustrating, but this is exactly the two lines that you're going to need to inform the user that that's the situation. Okay, so if I'm black or I'm not playing at all, then the computer is going to have to move first. So I say start position, go, get me the state, and by the way, start thinking for 3 seconds at least. And here it's the opposite. I mean, here the opposite side. So we're going to wait for me to make a move. So I'm not going to say that important word go. I'm just going to set up, say that it needs to think 3 seconds, that we're starting at the start position. And again, give me the state, right? I always want to know the state. Especially the legal moves is why I'm doing this in the beginning. I want to get the legal moves for both sides. Okay, and then after I say go, when a message comes in that has best move in it, so let's see, it gives you a bunch of extra information, but at one point it'll say best move, right? Best move, and that is the best. That's the one I'm gonna make. I'm always gonna make the best move that the engine recommends, obviously. Um, and so I'm gonna stop loading after a first move. I mean, this executes every best move, but if it's already on false, then nothing changes, so it's no problem. So this really only has an effect the first time after a game has started. And then we're going to wait at least 200 milliseconds extra, and this is because of the animations. So sometimes, because I said it's a minimum thinking time of 3 seconds, it's not that relevant. Um, but I've noticed that even though you say there's a minimum thinking time, at the very end of the game, it knows kind of what to do to have a checkmate, the last 2 moves or something, it starts being super fast. So it just responds immediately, and that kind of doesn't look that good in my interface if it's too fast, because you need that little animation time, which is about 300 milliseconds. So I'm asking it to, before I actually submit the move that comes in, I will wait 200 milliseconds um, before sending it onwards, right? So barely noticeable normally, and very important when the engine starts responding super quickly with a bunch of moves. Okay, so and again, I'm filtering out the checkers and using the set chess reducer to get those checker values out of it, and save them. All right, so it's just a list of strings of coordinates. And the same with the legal UCI moves, but in this case, it's not coordinates, but it's move, which is basically 2 coordinates next to each other, um, and those I sent one as well. Okay, um, well, now we've discussed the engine, and I've shown you the responses of the engine. Now I can quickly maybe look at the rest of the interface, kind of how it's built. Um, let's see, where do we start? So there's one trick that I think is the most important for other programmers to use, other developers, and that's actually this case of drag and dropping. If I want to drag something and I want to drop it again, because I see a mistake that a lot of developers make, which is the way they handle the movement and the dropping and the way they attach the handlers, especially with a React app. So let me show you what I mean, right? So um, let's see first where we start, right? This is where we start returning the divs, and let's see, this is for the square nodes. I'm generating the board, basically all the squares. And when you start, when you click on so touch start or mouse down, because this can also be played on a phone. So and then it would use touch instead of mouse. You can replicate this by clicking on this little device emulator and say that, for instance, now I'm an iPhone 5, and now if I want to move, it doesn't use the mouse, right? This little circle, you can see it doesn't even look like a mouse because it says no, this is supposed to be a finger, right? So it uses touch start instead of mouse down. So I of course do both, and then we start. And this start function, here it is. First of all, you can obviously see that we start off with a type any, because later I will define both touch and mouse, and then get the target out of these two, because they have different interfaces. If you have a touch, then that's going to be a list of touches, because you can touch with multiple fingers. So I'm going to pick the first finger in the list. That's the one I'm going to use. And if you have your other finger accidentally touching the screen, then I'm just going to ignore it. I'm only going to take that first finger. And with the mouse, we don't have that kind of problem. We always have one clean indicator. So you just take the mouse, and then we take the target out of one of these, right? Depending on whether there were change touches or not. And at that point I have the target. It's nicely typed. I've got everything, and I can do my work. But now the important part is that this start function, as you could see, I bound directly to the object that I want to start touching. But now it comes to dropping, right? How do you drop? How do you end? And it's very critical that the moving and the ending of this touch start or the mouse happens on the complete top root level part of your document. So I can show you how I did this, right? So because we have an end, here's the end function, and we have a move function right here. So these two. And here we have a use effect that says whenever these end or moves change, we're gonna go to the document body, remove those event listeners, attach them again, but now with the new one, basically update these event handlers. And again, when we leave the page, we're gonna remove the event listeners again. Right, so this function cleans itself up. And I told you before in the previous video that I did, which was very long, I have to admit, I did say how a use effect works, and I'll repeat it again. This is where you do the effect, and then this is what executes when one of these changed and you're leaving the page. Those are the events that triggers this function that you return. So it's called the cleanup function, right? So whatever nonsense you did here, in my case, I added a bunch of event listeners. I have to clean those up. Okay, so that's very clean. Okay, now, so this allows me. The reason why it's so important to put it on the top level is because you don't want users to get that horrible experience of. Let me see. Of starting to drag something, then kind of, for instance, accidentally just going outside of it, and then it kind of starts messing up because it doesn't, as long as you're not moving or ending your click here, it would not be triggered. So you can't just put it on the board or even on the page, because then you could maybe drag it to the logo here and then it wouldn't work anymore, right? And then you would get into this broken state. So again, it's so important that if you're going to drag and drop anything in the page, you want to do it on the entire page. There's also another thing that's super important that I almost forgot and I fixed it later. I'll say it right now, is that whatever you're going to drag, where you're going to start dragging, right, where you're going to click the initial click, you want to put the touch action to none, because else you're going to end up in a situation where on the phone or other touch devices, you use your fingers drag and drop, basically that you use that touch action to scroll the page, and the page could still be scrollable, especially in mobile view, right? Like it's a very long page. So if you wanted to start drag and dropping something here, now I would actually start scrolling the page at the same time, and it would be completely broken. I wouldn't be able to actually move this piece because the page would be moving along with me. So you need to disable that by doing some CSS and saying that the touch action is none. All right. So, and there's also a bunch of other tricks with touch events and stuff that I think is useful to show. For instance, if I now use this selector and click on one of these, you can see I'm not actually selecting the piece. The pieces are down here, and they're always not clickable. What I'm selecting is only the board square. And the reason I did this is because now I can move this piece and it just follows my mouse, right? It has nothing to do with the square, and it's also, it doesn't interact with my mouse. It's a complete, that object itself does nothing. And you can see how I did that. I did it with pointer events none, which is such an, this used to be a SVG only property, or actually that's kind of its origins, SVG, but it can actually be used on any HTML element to completely make it not interact with your mouse anymore. There's another thing, for instance, that the iframe that I load in, that has the engine inside of it, Chrome at least has this thing where if the iframe is not visible in your screen, if you scroll past it, for instance, even if it's like very small, if it's like 1 by 1 pixel or 0 by 0 pixel somewhere at the bottom, if I scroll away from it, the engine would stop working, because Chrome only allows it to work when it's visible, right, to kind of reduce CPU wasting. Wasted CPU cycles or something. But obviously, since I was talking to the iframe all the time, I needed to always work. So the hack is to always keep it in the screen. And in this case, here it is. Here's my beautiful frame. And now there's an opacity 0 on it, obviously. So if I open it up now, you can see that there is actually an iframe here. Obviously, that page, the Stockfish itself, has absolutely no body. It doesn't say anything. It's just a script, and it's talking only to me through the post message, window API. So yeah, opacity 0, and again, pointer events none, because if any user clicks here, I want them to go to LuxGG. I don't want them to be clicking on an iframe, right? So pointer events none, used a lot. Touch action disabled or none, very important. User select none, so that if you accidentally kind of drag and drop, you don't accidentally select any of these numbers or these buttons, right? So or actually these buttons you can, but this board is where you really have this kind of complicated interaction. So that's where I put it on. Okay, so wonderful. Let's continue. Start, and now just to quickly kind of, well, nothing is quickly in this video. I'm sorry for torturing you for this long, but in the start of the game, no, we're gonna go to start first and see what happens, right? Just to see how it's done. Okay, if we're already dragging something, we're done. If there's no piece on this square, we're done. If this is not the color, of the current turn, I can't. This is an opponent piece, so I can't move it. If the game is already drawn or lost, or it's not my turn again, like just stop. So these are all the guards, right? I call these guards because they guard the function from executing when it shouldn't be executing, right? So it's a guard, and you can guard in a lot of functions. That's how you want to do it. You want to use this return statement a lot, and I see that as the big difference between a good programmer and a bad programmer. Use the flow of the code correctly. And don't say if and else, right? I mean, you can just do if, and then if the condition is true, return, and then basically everything below here is else, because you returned all the ifs already. So, and it prevents your code from going too much, to nest too deeply and to become unreadable. So yeah, return statements, extremely important. And if you do it in a one-liner, then I love you, and this is called a guard, and this is the best way to program. So, period. So, okay, after these 4 guards, we are assured that this function is supposed to fire, and we're supposed to start dragging this square. And now I'm going to dispatch to the reducer and say, okay, this is the piece that I'm trying to move. Can you find out what the engine told you what the legal moves were for this particular square, right? And that's going to become available to me on the property available squares. So I'm going to say set available squares. All right, so I do that right in the beginning to start drawing those dots, and then I'm going to figure out what where my mouse is or where my touch is. Okay, so how do I do that? Well, I have this other function, get offset, which is going to take the target that I clicked on. It's going to figure out the offset for that piece. So we can quickly look at this. This is a pretty DOM heavy, document object model heavy function. Really goes into the depth. gets the bounding client rectangle. I mean, this is the kind of stuff where people used to install jQuery for, basically. But nowadays, there is enough consistency between the browsers that you can actually do it directly with the document object model. So it's perfect. It's not too much code. I mean, okay, it's pretty serious, but at least we now have full control, and it looks good. And you can also see that there are some fallbacks for different browsers. I mean, okay, it's not the most clean code, but you have no way around it if you want to support your web page in multiple browsers, which I actually haven't tested yet. I've only tested on Chrome right now. Again, this product, I just finished building it couple days. Okay, so maybe just 2 days. Anyway, okay, so box, we know the rectangle, and we're just going to find out what the distance is that I'm starting to drag from the left and the top, right? From the left and top, I'm trying to get that offset. And it's very important because then once I know the relative position, I can move this piece that you're dragging with an absolute relative inside. So to just show again, we have to not go to the square, we have to go to the piece. But a piece is inside here, and this one is position relative, because what position relative does, if you say top or left as a value on it, you start moving the piece. Let me show you. So I'm selecting some piece right now, and I say left 100 pixels, and now you see that I moved my rook. And it's relative to its original position. So that's exactly what I want. So all I need to do now is take the starting position and save it here. Starting position is exactly of the center of the horizontal side, and a little bit above the center for the top. That's the perfect kind of feel good way to hold a piece, right? You can see that I'm just holding it in the middle, but also a bit to the top. And that's what I'm calculating here. And once I know that that's the start, then my move function will subtract it always. Will subtract the start, so it knows where it is currently in the page, where it's hovering, and it will subtract the starting x and y coordinate, and I end up with a relative amount. And the relative starts obviously at 0. That's when I start dragging. But as soon as I do a move, then we can calculate the relative x and y, and we can put that on directly on the element style of the element that I'm currently dragging. And also React, I made sure that React does not change the styling of this particular piece of the span inside. Right, it moves the piece, and that's an interesting thing I did. Well, maybe we're going a bit too deep into this now, but well, that's this video basically. Welcome to the show. But we have a div surrounding the span. There I control the class name and the styling for left and top with React, and that is only to represent the current state of the board. And if you're trying to move a piece, then I'm not going to change this part. I'm not going to change the div outside of it. That's going to stay in the position, because technically the state of the board is not changing while you're moving this, because only when you let go do I want to change the state of the board. So that's why I have this span inside where I actually put the piece in, because then I can move that one to do my stuff. And again, this whole thing is unclickable. The only thing you can really click on is the square that's behind it. And also I can then do this hover effect. See the white border around when you try to hover? You see the white border? I can do that nice hover effect because I'm not hovering over the piece, because the pointer events are none. So basically you can act as if I'm not even holding anything. And I can make hover work with simple CSS values. Okay, so now we've got that. We got the move. I told you about the relative amount that's being calculated and directly applied onto the span. And of course, at that moment, it's the most important part is when we're done, when the end is, when I let go. Obviously, when I let go, I want to make sure that we have a board that's there and we have a element that was being dragged. And then if it is, then I'm going to find out how's it called what was being dragged. I'm going to find the index of that piece in my memory, and I'm going to update that piece. Okay, so how do I do it? I need to calculate the size of the square. So I take the current width of the board divided by 8 and take also the edge to the center. So I need half a square to create the edge to the center. And then I'm gonna get the exact location that you are away after dragging in squares, in the amount of squares, right? And then I can just take the coordinate of that piece and I take the index of that piece of the coordinate. So in columns and rows, those are constants, that represents the coordinate system. So I can always say what's the index of C, and then I get a number, right? So then column 2 in this case would be C. So now I go from strings, I go to a number, and then I can calculate with it, right? So I get this index, and then yeah, then we just then we can calculate the new row and column, and we can then see if this was available. And it says only submit valid moves to the reducer. So again, I'm checking these available squares that was calculated when I started dragging. I'm going to see if by now that I'm going to let go, it has been calculated that this is an available square. And if it is, then I'm going to send this to my chess move reducer, which is the most complex, and in this entire application, the most complex reducer I've written. That's also why I wanted to show this, make this video, because this is really the first time for LukeGG, for this particular project, that we're going to another level of complexity, especially with this chess move function. Now, I haven't done any refactoring yet. This is just the first version, and like a book with the first draft, it can get quite difficult to understand. But I think it's still important that if you're a good programmer, that you learn how to work with your first draft. Things are not always going to be that beautiful. You don't have time to refactor everything all the time, or you don't really want to. That often happens, especially with hobby projects. If you're not doing it professionally, if nobody's paying you, you just want to move on, and you want to make sure to avoid any big mistakes that are going to bite you later. And you want to make sure that you're very, very good at reading code. Um, and that's what I hope to help you with here. Let's have a look at the code, because this chess move function is so key. By the way, the rest is just removing the style attribute, so the span pops back into its place. But because we're updating the surrounding div location immediately as well, you don't see it, and it instantly pops to the place where you let it go. So we're doing those two things at the same time. We're also putting the drag current on null so that you can select another piece again. Okay, perfect. So this is done, and now we move on to the chess move method, the reducer. And you can see this is a bulk. I mean, this guy is 364. Oh wait, is that the end? That was the end, right? Yes, 362. And it starts at 158. I mean, this is a bulky reducer. I actually might move parts of this stuff to a utility folder, perhaps of a utility file for utility functions. But again, right now I don't need to. It's the only function that is really complex. So, oh well. If you're in the store, you're probably there to read this function. Okay, so first of all, we know the coordinate of the move. I'm also going to give the state chess, which is of course the root of all these variables that I want to recalculate or use. I'm going to give that a short name of C, because then my code reads a little better because of all the C's everywhere. Okay, so that's just a little renaming to make things a bit nicer. Okay, so we're going to put the latest move to this move. And if that latest move was none, then we're done, because that means that the computer, only the computer sends this value as a value when it can't move anymore, when it's checkmate. So when you own the computer, it's going to send none. Okay, so now find the moved piece. We're going to break down that string, and like I told you, we have 5 letters, and promotion is a weird one that again almost never happens. Like when it's promotion is the only time when this is actually a value. Normally you have 4 with 2 coordinates where we used to be and 2 coordinates where we want to be. That's it. So we're going to slice this string up, this move up, into these variables so that we can start working with it. And then we're going to find the piece in our memory. And if we can't find it, then obviously something has gone wrong. So this should basically never happen. because you're supposed to always be able to find the piece that someone wanted to move, else your logic has to be wrong. In the beginning, I had some issues, for instance, with the engine starting up twice, 2 iframes, and then you got 2 times it wanted to make the same move, so the second time it would fail because the piece was no longer in that position, so I could no longer find the original piece, right? So this is exactly what I mean with the kind of problems that can happen, and that's why you want to catch it here. And also it's nice because now you don't have to keep checking if it's null or something, like you just check it once. So again, this is that beautiful guard, this is a guard, this is a guard, if return, that's how you write clean programming. So now that we've decided that we're going to make the move, right? You've passed the guards, we have found the piece, you're another computer that says it's checkmate, we're completely ready to move on. And that's why we're going to put the available squares back to nothing, because I want to visually clear away those indicators that say where you could possibly move this piece, because we already decided that we're going to move it. Okay, now we're going to move and attack. So we find if you're attacking a piece, which again is not optional, maybe you're doing just a normal move, but maybe you're attacking. So we're going to figure it out. And if you are, then we're going to say that you've taken that piece. I mean, we know that it was a valid move, so we know you can take this piece, so we can just do it right away, right? And we say attacked piece is taken. Now an important thing is the reason I don't remove the attacked piece from the list and I just say taken is true is because else React could maybe redraw the way that these pieces are put into the document object model. If you change the length of a list, and especially because I use the index of the piece or to signify where it is in the list. Wait, let me show you. It's going to help me to show you the exact place where I do this. All right, so here we have the piece, and the only thing making it really unique is this index here. So I'm using this index as the key, and therefore I can't remove parts of this list because that would change the indexes and things would kind of visually shift around this board. So this one would go here and that one would go here if I removed one of the pieces from the list. Now there's other ways to go around it. I could change this key, and again I could sort things out. But another easy and great way is to just say that the piece is taken like this. And another advantage then is that you can kind of fade out the piece instead of just deleting it right away. And you can see that when I let the computer run. Let's see if it takes something. Now we have to watch very carefully. But as soon as it takes a piece, you can see that the one that's being taken kind of fades out. And that's only because of that property, right? Taken is true. If I remove it, so there you go. And you could maybe see it, like it kind of see that quickly fades out. So it's better for the eye, kind of smooth user experience. And by not removing it from the list, but instead just saying that taken is true, I can enable CSS transition and the piece is not completely gone from memory so that I can't map over it anymore. So that's another advantage, right, of using a flag instead of taking it away from the list. Okay, so remove any attacked en passant squares. So if I move the piece to an en passant square, then I need to remove. You haven't really attacked, like in a traditional sense, you haven't attacked the pawn that you're just taking away because you're going to a square which is not where it is. But again, that's where it's so useful to save that en passant piece. And here you can see that I say, hey, if you move to a coordinate that actually was the en passant square that we calculated before in the previous move when someone moved the pawn twice up, then I know to remove that pawn, right? So I'll find that pawn, either one behind or one below or one above the current value that you selected. And I do that because I know if you're white it's going to be capital P, and if you're black it's going to be lowercase p. So then I know if it's either one above or one below anyway. And then if I found a pawn that I was supposed to remove, then I'm going to say that it's now also taken. Right, now we do this after every move. We check if I move the pawn and I moved it up with 2 squares, then I'm going to say that the square behind it is an en passant. Right, so the value that I use here is basically happening for the round after. But if you're moving the piece and making it able to be taken, we're doing that here. signifying that here. We also need this value to calculate the fan code that I want to give to my engine later. So again, very important to calculate this. By default, it's just a dash if no pawn has been moved 2 squares up. Okay, and now the castling logic, which again, I could also do something about telling the engine what move has been made and then getting it out of there. This was kind of part of the original code before I started using the engine for certain calculations. But I did find out that the way this right now works is that I ask the engine after a move what the current state is. But actually, I ask it kind of before the move, and then I make the next move, tell the engine that I did it. It comes up with a return possible move and tells me the current state. So I didn't want to ask for the state twice, because then you would have to update also. No, you would basically still need to calculate the fan code. Basically, that's my issue. So I didn't figure out yet how to get that castling in another way. There is most likely a way, because you can probably just tell the engine like, hey, I made this move, calculate the fan score. Anyway, so far I haven't done that, and I've just said that I'm going to calculate castling myself. So it's a little complicated, but we can just quickly go over it if you want. I mean, we got the rook, the white rook, and it has 2 columns where it can be in, and if that's the piece that we're moving, right, the original piece, after you've moved the rook, you can't castle in that direction anymore. So that's why I'm saying here you can't go to the queen side anymore. I'm taking that out of the castling string because you moved the rook that was on the queen side, on the white queen side. And I basically do the same for the other rooks and the other sides. Very straightforward. Okay. Also, if your piece has been taken, so instead of it being the one you moved, it was the one taken, then of course you can't castle in a location where when your rook has been taken. Basically, that's all I'm saying. So you can't castle that direction either. Okay, and then if you moved your king, well, then it's completely done because you can't castle at all anymore if you moved your king. So I take away both options. Okay, and what else? Well, if you moved your king, you can't castle anymore, sure. But if you moved it to one of the castling positions, which should be one of the legal moves, right? We've already passed that check, so we know that it was okay to make that move. Let's quickly go into that state, by the way, just to show you how to castle. It's not that I'm an expert at all. I mean, I can't even move my pieces, it seems. There, time to castle. There, you can see I move here. And as soon as I let go, the rook moved. And that's what I'm doing here. I'm saying, okay, you moved your white king. You moved it to exactly this square. Well, in that case, we're going to find the rook and we're going to give it a new column. And we do that for all the 4 rooks. So, okay, now we've got all the logic down for castling. We've changed the castling availability, and if you actually made a castling move, we moved the rook to the right of the king or to the other side of the king. It hopped over the king, the way that castling works. Okay, and finally we have promotion. Promotion is, of course, when you're about to reach that end. I showed you before that when you move your pawn to the end of the board, you can pick another piece, and if you, so here I can say if your original name P, if you moved your white pawn to row 8, then I expect to have a promotion in the move, right? You need a promotion that's that fifth letter that I told you about in the move code, and if that doesn't exist, that means it has to have come from the interface. Because if the engine gives it, it always gives you that 5th character. It always immediately tells you in the first move, hey, I want to put a queen there, I want to put a rook there, I want to put a knight there, I want to put a bishop there. So my interface doesn't. It just says, hey, you moved the pawn there, so I'm just going to move the pawn there, and then in this reducer I'm going to figure out, wait a minute, I'm supposed to find a promotion if you've moved a pawn to that row. And if I couldn't, then I'm just gonna put the request promotion on true. So now I'm gonna ask the user, what the hell, like you need to promote first and then make a legal move instead of giving me this fake move. So I'm even gonna return. I'm not even gonna continue this function and as if you've made a move. We're just gonna stop right here because you haven't made a move. You haven't made a legal move. All you've told me is that you intend to uh, promote your pawn at that specific square. Um, but now I need to know what you want to turn it into first. So that's why I do this, I return. Okay, but this is if we don't find a promotion. If we do find a promotion, then this is just a legal move. And I'm going to update this original piece, this pawn, and I give it a new name, because the name, of course, changes what it is. So I'm going to rename it to whatever you said in the promotion character. And I'm going to do it in the case of white, capital P. I'm going to change the promotion to capital 2. Right, and then I'm also going to say that we're no longer requesting a promotion. So then, of course, that little pop-up that says that where you can select what you want to promote to flies away. Okay, perfect. So we did the promotion for white. Now we have to do promotion for black, and we're good. Finally, we're going to update the row and the column of the original piece, the piece that I'm selecting, to the thing that you want to go to. Very straightforward. We're going to also obviously switch the turn. So very easily, if the turn was white, you become black. If the turn was therefore black, it becomes white. So just a little toggle. Also, when it's white, we're going to add a full move number to the turn, right? So that's again used for that fen code that I want to send to the engine. It needs this number. And the half move clock, same thing. That's that other number. This is basically the end, the last 2 digits of the fen code. Okay. Now the remaining pieces. So this is very important to calculate insufficient material. So I have white and I have black, and I create 2 arrays of strings for both sides, so that while I'm recalculating the squares by going over the pieces and uh, putting the pieces inside of the squares, right? I do that after every move. While I'm doing that, I'm also going to count the pieces that are not taken. So if it's taken, then we immediately return the squares. We act as if they don't exist, because obviously they don't exist, they're taken. But for the remaining piece, we're going to say that this particular name gets pushed into the array of that color. Okay, and then later, when we're done calculating the squares, I can say, okay, when do we have no material, or insufficient material is the better word. Anyway, I called it no material because I thought insufficient is way too long of a word, so I'm just going to use no material. Not enough for a checkmate, at least. That's when white has less than 2 pieces remaining, or 2 or less, I should say. If you have 3 pieces, doesn't matter which ones they are, you have a chance to have a checkmate. So, and it's for both sides, by the way. So again, both sides have to have 2 or less pieces, and out of those pieces, none of them, if any of them are not one of these 3, then it also is not insufficient material. And you can see that a queen, obviously, if you have any queen left, it can never be insufficient material, because if you have just the king and the queen, you can make a beautiful checkmate. But if it's a knight or a bishop, um, in that case, so 1 knight or 1 bishop, and of course always the king, because that one cannot leave the board. It's always going to be on the board. So if you have 2 or less and it has 1 knight or a bishop, those are the only ones inside. So then you could lose. You have insufficient material, and if both have it, then it's done. You neither can win. So this is a kind of a double negation search. Right, no and no. But anyway, um, perfect. So now we've basically calculated all the possible things that this board needs. Now the only thing I need to do, the final part, is to get the fen code that I need to give to this engine. The way that the engine can see what the state of the board is. Very important. So the first part was the fen pieces, And again, I have to do this empty count. It's that weird format where I loop over the whole, all the squares, right? I go over all the squares and reduce it down into this Venn code. And again, the way it works is by calculating again out of the index, which is the single number from 0 to 63, which is in total of 64 squares, right? I need to take every row, and between every row I need to put a slash. That's the way the format works. And if it's empty, then I need to remember that that empty number and add it up until I'm either at the end of the row, which is what is this is the case, right? Because this is when a new row begins. Modular how's it called? Module 8, I think it's called. Is that how you say it? Modulus. Anyway, modulus 8 is 0. That means that it's at the start of the next row. So then I need to add that number of any empty squares that came before it and a slash after, and then I can move to the next one, to the next row. And again, if empty is if there empty count goes up and I return. Anyway, it's a little complicated, and babbling about it probably is not gonna make you understand. But copy the code, download it, have a look, and you can figure out how this Venn code is created. It's very kind of straightforward, really. In the end, you just need to understand reducers, and in general, map and reduce, those two functions are the key. And even the map function, right, is actually a reducer as well, but it's just an easy reducer. And the defined function is a nice one because it's kind of a reducer, but it stops when it's true. It stops after it found something. So it's a little bit more efficient, especially with large lists. You always want to use find instead of reduce if you're just trying to find a single value. But theoretically, though, if you don't care about performance, every single method that exists is a reducer. It's always a reducer because a reducer is very powerful. You can decide what you want to start with. In my case, I start with Venn pieces and empty string and empty count is 0. And then in the end, I'm going to get that piece here. The memo is going to keep coming back and I can change it and I have to return it always, right? So I'm changing that memo. This is the thing I'm reducing into, as I call it. Then this is the first object that you're looping over. In this case, I'm looping over the squares of this chess state. So I'm going to get one square, and the third variable is going to be the index in this array that you're looping over for this square. So yeah, and that allows you to take any list and transform it into another list, or transform it into a boolean, or in anything you like, because you can decide yourself how you want to incrementally change this object, this value, to another value. Okay, and finally I put together the code by taking these Venn pieces, this state I calculated, taking the turn that you're supposed to be. Oh, interesting. Oh yeah, right. So this used to be, my turn used to be called white or black. Then later I changed it to W and B to be more like the engine because I liked it. So this is no longer needed. I can just do a C turn because it makes no sense to have this because C turn is W, then use W, else B. I mean, that makes no sense. And I can hover over it and even see that the only two values that this property can possibly have is W or B. So yeah, nice. Nice little bit of refactoring on the spot. Perfect. So yeah, we've gone over the entire reducer. We've discussed every single method that exists in this page. We've also gone over the complications of drag and dropping, which is, I think, is the most useful part of this. Maybe it would make sense to have a quick look at this engine on the Stockfish side. So this is the iframe that I was talking about. You can see I'm just loading in Stockfish.js, which I downloaded from GitHub. So again, thank you very much, Stockfish developers. It's an open source project, obviously. Incredible to work with. I've really enjoyed it. And I'm going to talk to it here. So I'm going to say again, listen to any messages that come from the parent because I'm inside of an iframe here, right? So there's a parent that I'm going to listen to, and it's going to send me events. And then here I say if there is no stock, if I get a message but there is no Stockfish yet, so this only executes once, then I'm going to start a Stockfish. I'm going to create it, and I'm going to say as soon as Stockfish sends me a message, I'm going to send it to the event source of this message, which will be my iframe. Right, so that's how I target it. And then I can also target the origin, which is very important for sending cross-origin resource sharing messages. Okay, so now we can send messages back, and obviously whenever I get a message, I'm always gonna send it to Stockfish. So this is just a simple middleman, this HTML file, between on the one side the engine and the other side the web page. And this allows me to host this entire 2.2 megabyte stockfish.js on a distributed network, right? Content delivery network like S3. And then I don't have to pay a lot of money for my EC2 server, my small EC2 server that's supposed to be just an API, not a, big heavy engine. And by the way, so this engine just runs, as you can see, this engine just runs in the front end in a separate iframe, which is great as well, because that means if you have a powerful computer, I mean, most computers nowadays are more powerful than a single process in the server that you're gonna get, right? As a user of an API. So if you can put stuff into the front end like an entire engine, I mean, my gaming PC here is gonna give much faster, results. And in this case of this engine, the more time, the more CPU cycles you give it, the stronger it's gonna be, right? So in this case, it's perfect to have it in the front end and be able to dedicate an entire thread of Chrome to this Stockfish. And if you then give it 3 seconds between every move, it's gonna get real hard. I mean, I haven't been able to beat haven't been able to beat this engine. Obviously, I mean, I'm not that good at chess, so this engine is too strong for me. But I've been beating myself just to test. All right, so wonderful. That's the Stockfish side. Well, I think we've really. Oh, maybe the last thing I want to do is just talk about this beautiful rotation right here, because you can see also that these little numbers, these coordinates that are inside here, they also change places, right? And it's such a hack, because obviously I didn't want to recalculate or change the way that the logic really works. I just wanted to visually rotate the board, and it was actually, I realized, really okay to do with a transform. So this is a transform. It is, so if you have the rotated true in the store, then the rotated class is put onto the board, and then I can just rotate the entire board. And obviously everything would be upside down, including the pieces and the text. So I need to rotate those again back to kind of make those visible. And you can also see that it kind of creates this nice visual effect where they turn visually as the whole thing turns, which I kind of liked. So everything has a transition on it. Not everything, but the objects that I'm rotating have a transition on it. Okay, so that's what I do here. And the same is with this powered by Stockfish chess engine. That one needs to be rotated too. But that one also needs to be flipped, because it can't be on the top. I always want it to be on the bottom. So I just kind of, as you can see, as I click, it flips to the other side while it turns. And the same with these numbers, they flip to the other side as it turns. So that's kind of how that rotation works. It's a bit of a hack using transform rotate, but hey, it works. And the only part of the logic I had to change was actually the moving of a piece and the calculating of the ending of a piece. Although actually no, I do that here too, because what I do is the relative y and x that is used in this calculation is rotated as well, because theoretically, while I'm moving up, when this board is rotated and this is transformed, technically I want to be moving down. That's kind of how it works, right? I want this piece to move down because it's actually rotated. So that's why I just do, if it's rotated, I do it times -1. That's the relative y and the relative x, and that's going to give me the correct calculation at the end. So yeah, now we've discussed everything. Yeah, every single thing that this page has to offer. And it was a lot of fun to build. I hope that it was useful for you to see. If you stick to the end of this video, then wow, you're very hardy. I commend you for your vigilance, and I'm happy. And if you have any questions, let me know. Yeah, I hope you can build some cool stuff with this. Oh, it's 20 past 1. It's time for me to leave. So thank you again, and well, till the next video.